Hello and welcome to The Space Above Us, Episode 5, Project Mercury Flight 3, Friendship 7, An American in Orbit. Today we'll be talking about Mercury Atlas 6, the first orbital spaceflight by an American. As you'll recall, at this point NASA had already executed 2 human spaceflights, with Mercury Redstone 3, Freedom 7, and Mercury Redstone 4, Liberty Bell 7. Both of these flights used the less powerful Redstone missile to loft their payloads into suborbital trajectories, with the capsule splashing down a few hundred miles east of the launch site in Florida. The Redstone missions were immense accomplishments that buoyed the spirits of the army of engineers and technicians working for NASA, and were important test flights for the program, but were mere preludes to the real prize, Orbital Flight. I talked about this a little in the episode on Freedom 7, but it's an important point, so I'm going to repeat myself a little bit. Orbital Flight is a whole other ballgame compared to suborbital flight. Each of the Mercury Redstone missions lasted about 15 minutes, spent only 5 or so of those minutes in space, and had a relatively small area where the capsule would be recovered. With Orbital Flight, things are a bit different. It's so different and introduces so many complexities to the mission that I'm actually having a little trouble figuring out how to start explaining it, so I'm just gonna go for it. Achieving orbit requires a vast amount of energy, even compared to the suborbital flights of the Redstone missions. Both suborbital flights, and this first orbital flight, would achieve roughly similar altitudes, 187 kilometers, 190 kilometers, and 248 kilometers respectively. But altitude isn't enough. At the time of booster engine cutoff, Freedom 7 and Liberty Bell 7 were both traveling at around 8,200 kilometers per hour. That's pretty fast. To give you an idea of how fast, a cruising Boeing 747 flies at around 900 kilometers per hour. A bullet from a rifle travels at around 1,500 kilometers per hour, and the SR-71 Blackbird flew at around 3,500 kilometers per hour. But fast as the Mercury Redstone missions were, it was not fast enough to go so far horizontally that the Earth would curve away at the same rate as the capsule's fall. To pull that off would require accelerating the capsule to a whopping 28,000 kilometers per hour. That's almost 19 times faster than a speeding bullet. The Redstone missile had performed admirably, but just wasn't capable of getting the heavy Mercury capsule up to those speeds. NASA needed a new, more powerful booster, the Atlas. The Atlas launch vehicle was an intercontinental ballistic missile developed for the Air Force in order to throw all sorts of nasty stuff at people far away. Thankfully for NASA, that nasty stuff was roughly the same weight and shape as the manned capsules they wanted to launch. Atlas was a pretty interesting vehicle. In order to save precious weight, part of the structural integrity of the missile came from the pressurized fuel and oxidizer tanks. Using this balloon tank strategy meant that if the tanks lost pressure, the entire vehicle would collapse. A good way to think about this is by thinking about car tires. A car isn't held up by the rubber in the tires, it's held up by the air contained by the rubber in the tires. If you let the air out, the rubber will collapse and the car will sink to the ground. The Atlas tanks were a similar idea, but with results that were more catastrophic than annoying. Another unusual feature of the Atlas missile was its staging strategy. For the uninitiated, most rockets are really a stack of several smaller rockets called stages. The flight starts with the bottom rocket firing. When it runs out of fuel, it's dropped off the back to save weight, and the next rocket fires up and continues on its way. As a quick example, the Saturn V had 3 stages. It lifted off with 5 engines on the first stage firing. As the first stage ran out of fuel, it dropped off the bottom, allowing the 5 engines on the second stage to ignite. Then still later in the ascent, the second stage would drop off, and the third stage would complete the orbital insertion with its single engine. The Atlas had 3 engines at liftoff, 2 booster engines on the side, and 1 sustainer engine in the center. All 3 would ignite at the start of the mission, but partway through ascent, the booster engines would shut down and fall off. What makes Atlas strange is they didn't just drop off the bottom or off the side like you may have seen other rockets do. Instead, it did this bizarre thing where the whole bottom of the rocket dropped off around the sustainer engine, which remains attached to the vehicle for the duration of the flight. They called this a stage and a half. The reason they did this was that rocket technology was so new at this point that they were unable to reliably light an engine in mid-flight. With that constraint, the solution of dropping off 2 extra stages and leaving the center one on the whole time makes a lot more sense. It's still pretty strange though, and I'm not entirely sure why the structure surrounded the sustainer engine. The Atlas, specifically the Atlas D subtype used for the Mercury missions, had a thrust of 1,300 kilonewtons at liftoff, and was capable of lifting 1,360 kilograms into low Earth orbit. It was a beast compared to the measly 350 kilonewtons of thrust provided by the smaller Redstone rocket. So, why did NASA need the Redstone at all? The Atlas was still pretty new technology at the time, having only had its first launch in 1959. The folks at NASA knew that it was likely to take considerable time to get the Atlas to the point where it was reliable enough to put humans on top of it. With that in mind, they looked to a number of other boosters to help them test various elements of the Mercury capsule while the Atlas was still in development. These boosters include the Redstone, which we've already talked about, the Little Joe, the Big Joe, and one disastrous test on a Scout. These smaller rockets don't play a direct role in our story here, but, well, they exist. What's sort of funny about the plan to use the Redstone for early testing while the Atlas was worked on was the Redstone wound up with enough problems of its own that while their missions were still useful, the lead time between Redstone and Atlas was much less than planned. There was even a point where Redstone flights would be flying after Atlas flights had already been achieved. Eventually, these later suborbital missions were scrapped in favor of concentrating on orbital flights. One more fun fact about the Atlas rocket. A new chemical was developed to help prevent the shiny metallic skin of the vehicle from corroding or rusting. The chemical displaced water, which would allow the rocket to remain corrosion-free in the muggy Florida climate. It turns out it took them 40 tries to get the formulation right. Perhaps you've heard of this water displacement Formula 40 before. Let's just call it WD-40 for short. John Glenn's mission was to fly around the world not once, not twice, but 3 times, with each orbit taking around 88 minutes. Take that, Jules Verne. Right off the bat, this necessitates a global tracking, communication, and recovery network. Nowadays, that might not seem like such a big deal, but when they were planning this, it was still the 1950s. There was no internet, no communication satellites, nothing like that. If NASA needed a global tracking and communications network, they're going to need to build one themselves, more or less from scratch. The tracking network was a real accomplishment, and the full details would be too much to go into here, so I'll just give a brief overview. The basic goal was to ensure that no matter where the spacecraft was in its orbit, mission controllers would be able to communicate with the astronaut, track the spacecraft's status and position, and if necessary, send commands to the spacecraft, including starting an emergency reentry. The requirements were to ensure that the spacecraft would be out of range of the network for no longer than 10 minutes at a time on the first few orbits, and was able to establish contact at least once an hour on later ones. That second point mostly applied to the later missions, which had a longer duration. The fact that the astronauts were out of contact at all, let alone for up to an hour, may come as a surprise, and certainly did to me, but these were the early days of the space program, and NASA didn't have a nice network of tracking satellites in place yet. A number of ground stations were established all around the world underneath the planned orbital trajectory of the capsule. Each station had different capabilities, ranging from radar tracking only to full command and control. So for instance, the station at Eglin, Florida only provided radar tracking, while the station at Mooshea, Australia tracked the capsule with radar, received onboard telemetry, had the ability to issue commands to the spacecraft, and had voice communication capabilities, with fellow astronaut Gordon Cooper providing a familiar voice. Since there were so many stations with different capabilities, I've had a little trouble nailing down exactly how many there were, since different books seem to not count stations that were unmanned or were lacking particular capabilities. So I'm just going to go with the most common number and call it 18. Due to the sometimes patchy communications back with the Mercury Control Center, the NASA engineers operating the stations had to be largely self-sufficient. These young technicians and engineers, mostly in their 20s, mostly having never been overseas before, had to make tough command decisions in the brief periods when the spacecraft was passing overhead. Each station funneled information back to the MCC largely by way of local telephone and teletype lines, eventually routing through the Goddard Space Flight Center in Greenbelt, Maryland, where a massive computer helped collate all the data. The data stream to the computer peaked at around 1,000 bits per second. To give you an idea of how little information that is, If we assume each character uses 8 bits of data, a single tweet's worth of text would use 1,120 bits. This cobbled-together worldwide network, with all of its limitations, was an incredible feat of engineering, communication, and teamwork, and it served the early space program well. Talking to someone who could be anywhere on Earth south of Florida and north of Australia is tough, but you know what's tougher than talking to them? Recovering them. As the spacecraft makes its way around each orbit, the Earth rotates east underneath it, so the ground track moves further and further west on each pass. The mission plan for Friendship 7 called for 3 orbits, which would cover a massive, but manageable, swath of the Earth's surface. But if something went wrong, John Glenn could be up there for several more orbits, which would add even more to the area he would be flying over. The upshot of this is that NASA needed the capability to recover the astronaut more or less from any point on Earth. The astronauts were trained in survival techniques for environments as diverse as the deep African jungle to the scorching American desert to the somewhat more likely wide-open ocean. They also carried survival kits on board in case recovery forces were unable to get to them in a timely manner. My favorite part of the survival kit contents list is a shark chaser, which the source I read didn't feel the need to explain, so I leave it as an exercise to the listener to imagine what it could be. Thankfully for both the astronauts and the recovery forces, the expected landing zones were quite a bit more predictable. There were set points during the ascent and during each orbit where the call could be made on if an abort was necessary. Of course, there was also the expected landing zone in case of mission success. Outside of an extreme emergency, recovery forces could expect Glenn to land in one of these areas, with the landing zones resulting from a successful mission or an abort during ascent being the most likely. I could say a lot more about recovery strategies and implementation, but let me sum it up like this. The military helped NASA a lot, it took a lot of people, it was very difficult and expensive, and it worked amazingly well. Like the previous flight, the Friendship 7 capsule contained a number of changes and updates. One of the more significant changes was the switch from a heat sink style heat shield to an ablative heat shield. I briefly covered this in the episode on Freedom 7, but at the start of Project Mercury, there was no clear consensus on which heat management strategy would fare better, heat sink or ablative heat shield. Ablative shields won out in the end, but several heat sink shields were made and were used for the less demanding suborbital missions. The heat sink shields were made out of beryllium and essentially just got really, really hot, taking the thermal hit so the capsule wouldn't have to. This strategy proved to be problematic at the higher velocities required by orbital flight, so ablative heat shields were used instead. An ablative shield basically burns off little pieces of itself as it passes through the atmosphere. Each little piece sheds more energy away from the capsule. This is also why the spacecraft often look dirty when returning from space. They're covered in soot from the heat shield. Like Liberty Bell 7, Friendship 7 also had a centerline window for the pilot's use. Actually, all the remaining Mercury flights used a similar window, so I won't bother bringing that one up anymore. Friendship 7 also saw the only orbital use of the Earth Path Indicator, that nifty device that showed the approximate location of the capsule on a small globe of the Earth embedded in the capsule's control panel. There were also a number of small changes to the layout of the control panels and their various switches, dials, and handles. One interesting addition was 2 handles to depressurize and repressurize the capsule, which was intended for use in case of a fire. Why include a fire suppression system when you can simply vent all the air on board out into space? Just make sure to check the seal on your helmet first. Most of the control panel changes were pretty minor, but it's fascinating to see just how much they were refining the systems even at this early stage. The McDonnell engineers took the lessons learned by Shepard and Grissom and adjusted the positioning of dials to improve the pilot's scanning patterns, added new caution and warning lights, removed controls that were no longer necessary, and so on. The pilot of Friendship 7 was John Herschel Glenn. Glenn was born on July 18, 1921 in Cambridge, Ohio, becoming the first of 25 astronauts to hail from the Buckeye State. To paraphrase Stephen Colbert, one has to wonder what it is about Ohio that makes people eager to leave the planet. Glenn served as a pilot in the Marine Corps during World War II and the Korean War, flying transport planes and then moving to fighters. As a fighter pilot, he completed nearly 150 combat missions, including 27 missions with the Air Force as an exchange pilot. After the war, he made the switch from fighter pilot to test pilot, working with the fighter design branch of the Navy. In 1957, Glenn flew from California to New York in 3 hours and 23 minutes, the first transcontinental flight with an average speed faster than the speed of sound. In 1958, he endured NASA's rigorous recruitment process and was chosen as one of the 7 Mercury astronauts. In early 1961, he was informed that he was among the 3 astronauts who would pilot the first 3 missions, eventually serving as backup for Alan Shepard and Gus Grissom's suborbital missions. As a quick aside, I'd like to clarify something that I've perhaps been a little vague on in previous episodes. There is a distinction between the mission name and the capsule name. For instance, Alan Shepard flew the Mercury Redstone 3 mission in a capsule he called Freedom 7. John Glenn flew the Mercury Atlas 6 mission in a capsule he dubbed Friendship 7. For Mercury, the mission names are simply a combination of the capsule, which was always Mercury, the booster, which for manned flights was Redstone or Atlas, and a number representing how many times this combination had flown. The Mercury-Atlas combination had flown 5 times previously in a combination of test flights, 1 chimpanzee flight, and large fireballs. In Project Mercury, since each mission involved only a single vehicle being used 1 time, it's common to simply refer to the mission by its capsule name. By the time we get to Apollo, with its multiple capsules, and Shuttle, with its multiple missions per vehicle, people only use the mission name. As for Gemini, I'll explain why we don't get cool names when we get to it, but you can blame Gus Grissom for that one. The mission plan for Mercury Atlas 6, or can we call it Friendship 7 now, was completely different from the previous 2 manned flights. The plan called for Glenn to launch from Cape Canaveral like usual, but rather than splash down several hundred miles east after 15 minutes of flight, he would orbit the Earth 3 times. Though to be fair, he would still be landing several hundred miles east of Florida in the end. The actual mission activities were relatively simple, since most of the focus was simply on if such a flight was even possible. Glenn would exercise the attitude control systems in various modes, make observations of the Earth, attempt various astronomical observations, become the first American to eat while in space, from a tube of applesauce, and more activities along these lines. Project Mercury scientists pressed for more experiments to take better advantage of precious orbital time. One such experiment was to test the proprioception of the pilot, his sense of where his own limbs are in relation to each other. If you can close your eyes and touch your nose, you can thank proprioception. The proposal was to have Glenn close his eyes and attempt to touch various parts of his control panel. Needless to say, Glenn and the other astronauts were not impressed with the idea of closing their eyes and potentially hitting control switches at random. For this first orbital flight, the engineers and astronauts prevailed, and things were kept simple. The build-up to the launch of Friendship 7 was plagued by delays. The initial hope was that NASA would be able to at least replicate the feat of Yuri Gagarin in the same year. Having 1961 listed next to both accomplishments in the history books would be one small consolation. As the scheduled launch day approached and problems mounted, however, NASA had to concede that the flight would be attempted in early 1962 at best. The numerous scheduled launch attempts, which were all eventually scrubbed, led to much stress among the NASA engineers and much derision among the national press. After yet another delay, one congressman described the vehicle as, quote, a Rube Goldberg machine on top of a plumber's nightmare. I'm not going to go into the cause of each of the numerous delays, but let's get into just one to give you an idea of how a relatively small problem on the launch vehicle can lead to a major logistical problem. During the preparations for a launch attempt on January 30th, 1962, the checkout crew discovered fuel in the space between the fuel and oxidizer tanks. The source of the leak would have to be repaired, and insulation in the space between the tanks would have to be removed and replaced. This was bad enough, since it would take 10 days for the technicians to complete those repairs, but it was complicated by the fact that NASA now had 18,000 members of the armed services all around the world who had to sit tight for 10 days and hope that the next attempt didn't lead to yet another delay. While delays like this were to be expected, especially at this early stage, it is easy to see how the public began to get frustrated with NASA's efforts. This is just me speculating, but I would imagine that the public perceived NASA as especially ineffective compared to the Soviets, since no one ever heard about the Soviet delays and problems. They had the luxury of only announcing their successes after the fact, while keeping their failures secret, so they probably seemed like they were chugging along smoothly. NASA had to complete its difficult task in full view of the public. In case you're wondering what John Glenn was up to during all these delays, he just kept preparing for the mission. On the night before he finally flew, he spent his time rereading the Flight Controller Handbook section on the Automatic Attitude Control System. Finally, February 20th, 1962 dawned, and everything was ready for launch. John Glenn was awoken at 2:20 a.m., showered, had a good breakfast, and underwent a brief physical exam. Thanks to the built-in holds and minor delays, there was no rush to arrive at the spacecraft, and Glenn actually remained in the transport van even after arriving at the launch pad, waiting until he was needed. At 6:03 a.m., Glenn set foot into the spacecraft that would vault him into world history forever. Launchpad technicians began securing the 70 bolts that held the hatch to the spacecraft, and once again discovered a single faulty bolt. Perhaps determined not to allow any potential hatch issues to crop up again, Mission Control delayed the launch while the bolt could be repaired. Minor problems continued to mount, including a stuck valve and a power failure and subsequent computer reboot in the Bermuda tracking system, but liftoff time finally arrived. At 9:47 a.m. on February 20th, 1962, the two booster engines and single sustainer engine on Atlas number 109D fired up, and the first orbital flight of an American was underway. Capsule communicator Scott Carpenter famously remarked, "Godspeed, John Glenn," though due to a hiccup in the communication, Glenn never actually heard the send-off. Similarly to Grissom, Glenn reported a smooth ride until the portion of the flight approaching max Q, when he radioed down, "It's a little bumpy about here." 2 minutes and 14 seconds after launch, the side booster engines cut out, and the Atlas performed its unusual staging maneuver, leaving the single sustainer engine to carry Friendship 7 onto orbit. Only 5 minutes and 1 second after liftoff, the sustainer engine shut down as planned, and John Glenn was in orbit. The various parameters representing the state of the spacecraft trajectory were relayed to the computer at the Goddard Space Flight Center. The computer reported the conditions were so good that Friendship 7 could potentially remain aloft for 100 orbits if desired. The capsule separated from the Atlas booster, the posigrade rockets fired, and as it began its automatic turnaround maneuver, Glenn radioed down, "0G and I feel fine." First on the pilot's agenda was to exercise the control system and attempt visual tracking of the expended Atlas stage through the window. Glenn was to attempt to estimate the distance of the tumbling booster from his capsule. This was actually a fairly important task, since it was not known how well astronauts would be able to judge the distance between themselves and nearby vehicles in the blackness of space with no reference points. If two spacecraft were ever going to meet in orbit, it would be crucial that the distance between them be accurately ascertained. Glenn tracked the booster for 8 minutes as he performed other tasks, and when his estimates were compared to the downlink telemetry, it was revealed that he was almost perfectly accurate. Since the flight of Friendship 7 was expected to last for 3 orbits, a little over 4.5 hours, he wasn't quite as pressed for time as his two earlier colleagues. He was able to experiment a little with the microgravity environment, finding it could actually be quite handy. While taking photos, he needed to make some adjustments to his control panel, and was able to simply leave the camera floating in front of him as he made the adjustments. Only 20 minutes after departing Florida, Glenn was passing over Nigeria. He relayed to the Capcom station there that he was able to see what looked like a dust storm, and was informed that there had been high winds lately. While passing over Nigeria, he used the fly-by-wire control mode to yaw the capsule around 180 degrees in order to face the direction of travel. After passing through his first orbital sunset over the Indian Ocean, he attempted to make observations of a flare fired from a ship stationed below, but poor weather conditions made it impossible. Continuing on to Australia, he performed a number of astronomical observations. As he carried out America's first human observations of the night sky from space, he said, quote, "There seems to be a high layer way up above the horizon, much higher than anything I saw on the daylight side. The stars seem to go through it and then go on down toward the real horizon. It would appear to be possibly some 7 or 8 degrees wide. I can see the clouds down below it, then a dark band, then a lighter band that the stars shine right through as they come down toward the horizon." Soon after, Glenn established contact with the Capcom stationed at Mooshea, Australia, fellow astronaut Gordon Cooper, commenting that everything was going very well and he felt no symptoms of vertigo or nausea. He also joked, "That was sure about the shortest day I ever run into." 45 minutes after passing into darkness, John Glenn experienced his first orbital sunrise, which was accompanied by brilliant and beautiful colors, as well as a surprise. Shortly after sunrise, Glenn noticed that his capsule was surrounded by thousands of small luminescent particles. The particles were slowly swirling around the spacecraft and were in every direction he could see. Within a few minutes, the fireflies, as he later described them, faded from view. The mystery of the fireflies was solved on a subsequent mission, but I'll leave you in suspense for now. I like the firefly story because when you hear Glenn talk about it as he flew through them, you can hear this moment of, maybe this is just a normal thing that happens in space, because who could say? Everything was brand new. As Project Mercury's first manned orbit drew to a close, a problem with the spacecraft developed. Glenn noticed that one of the automatic yaw control thrusters had become stuck, allowing the spacecraft to drift out of tolerable range. The pilot corrected the issue, but with the thruster out of commission, the spacecraft just slowly drifted back out of range again. This moment was a disappointment for the engineers who had experienced a similar issue on a previous test flight of the Mercury capsule, but was also a huge vindication for the proponents of piloted spaceflight. When this issue occurred on the test flight, there was no choice but to return the capsule to Earth earlier than planned. But with superstar pilot John Glenn on board, it was nothing more than a mild annoyance and a slight drain on the fuel supplies. Glenn would spend the remainder of the flight manually keeping his capsule pointed where it was supposed to. Putting humans in space is incredibly difficult and complicated, but also adds enormous flexibility to your mission. Over the course of Project Mercury, as similar moments emerged, spacecraft designers began to see the pilot as more of an asset than a liability. Unbeknownst to the astronaut, telemetry indicated that there may be a far more serious problem with his spacecraft. If the data being transmitted from Friendship 7 was accurate, then the all-important heat shield and landing bag were no longer locked to the bottom of the capsule. After a normal reentry, the heat shield would separate from the capsule, dropping down and hanging from the landing bag, which cushioned the final splashdown into the sea. But Friendship 7 was not drifting serenely toward the ocean under a parachute. It was 100 miles up and speeding past Florida at 17,500 miles per hour. If the lock had disengaged, then the only thing holding the heat shield of the spacecraft was the retro-rocket package strapped to its center. Engineers on the ground debated the best solution to this potentially catastrophic problem. Nothing could be done by the pilot to resolve it, so nobody told him, a decision Glenn was not pleased with after the mission. The proposed solution was to instruct the astronaut to manually prevent the retro pack from separating after retro fire. The straps holding the package to the heat shield would rapidly burn off during the rigors of reentry, but the hope was that by the time this happened, aerodynamic forces would hold the heat shield in place. Maxime Faget, the chief designer of the capsule, indicated that leaving the retro pack in place should be safe as long as all three retro rockets fired. Otherwise, there could be an explosion. This was not a trivial decision. No tests had been done on the behavior of the retro package during reentry conditions, its effects on the aerodynamics of the capsule, or any potential damage caused by debris shedding off as it disintegrated. No one explicitly told Glenn about the problem, but he began to grow suspicious after repeated requests for the position of the landing bag switch, requests to try putting the bag in automatic or manual mode, and most alarmingly, questions on if he had heard anything banging around while performing maneuvers. The thinking was that if the heat shield was loose and the landing bag had deployed, then as the capsule rotated around, the shield would bump up against the sides of the vehicle. At one point, the Capcom and Canton, perhaps not getting the memo, even mentioned unprompted, "We have no indication that your landing bag may be deployed." To which Glenn responded, "Did someone report the landing bag could be down?" The astronaut assumed that the queries were in response to the fireflies he had seen earlier. As Mission Control struggled to choose the proper course of action in response to the landing bag telemetry, they received an unexpected call from President Kennedy, requesting to be patched through to the astronaut. The frantic technician who answered the phone tried to get the Mission Control team's attention, but everyone was too busy working the landing bag problem. Eventually, he was forced to tell the president, "Mr. President, we've gotten pretty busy down here now. I don't think we've got time to talk." Kennedy responded to give him a call if they got a chance and hung up. Despite the issues with the stuck thruster and some warmer than comfortable conditions in the capsule, the astronaut remained in good spirits, joking with Gordon Cooper on his next pass over Australia that he wanted someone to inform the Commandant of the Marine Corps that this mission ought to count towards his mandatory 4 hours a month of flying time. As the time for re-entry approached, Glenn received still more requests related to the landing bag and likely realized the situation. The jig was up when Mission Control instructed him to perform the re-entry sequence manually and to leave the retro package in place. All 3 retro rockets fired without issue, so one way or another, Friendship 7 would soon be back on Earth. As the capsule began to speed through the tenuous upper atmosphere, the pilot said he heard what sounded like, quote, small things brushing against the capsule. Before long, the G-forces began to mount, and the capsule was engulfed in a sheath of ionized air caused by its violent passage through the atmosphere. Glenn was able to observe pieces of the retro package passing his window, but the heat shield appeared to be holding. The capsule had survived peak heating, but wasn't out of the woods yet. It began to wildly oscillate from side to side, rattling the astronaut inside. Glenn attempted to control the oscillations, but ran out of fuel, first in the automatic system and then in the manual system. He made to manually deploy the drogue chute in the hopes of stabilizing his craft, but it unexpectedly deployed on its own at the unusually high altitude of 28,000 feet. From that point, the descent proceeded smoothly and with no problems. As he approached the water, Glenn manually commanded the landing bag to deploy and felt a comforting clunk as the heat shield dropped and the landing bag expanded into place. 4 hours, 55 minutes, and 23 seconds after launch, the capsule splashed down in the Atlantic. Not long after, the capsule was snagged by a recovery helicopter with the astronaut still inside and ferried over to a waiting aircraft carrier. And what specialized piece of equipment did the Navy utilize to gently receive the capsule and its occupant on the deck of the aircraft carrier? A pile of surplus military mattresses, of course. I love it. Glenn started the laborious process of disconnecting control panels in order to exit through the nose cone, but after a long and tiring day, and with the capsule growing hotter and hotter by the minute, he decided on an easier solution. He instructed everyone to stand back and hit the plunger to deploy the explosive hatch. In doing so, he received the only injury he sustained in the 3-orbit flight, a small cut to his hand from the plunger. The carrier crew helped extract America's new spaceman from the capsule, with the astronauts smiling and simply commenting, "It was hot in there." After getting a chance to drink a glass of water and take a quick shower, Glenn began the lengthy debriefing process. He underwent a brief medical exam, recounted the events of the flight from his perspective, and finally received that phone call from President Kennedy. The full debriefing examination process would take a number of days, but John Glenn had successfully completed his mission, and with it, the core mission of Project Mercury. The United States had placed a man into orbit and safely recovered him. Glenn went on to become, if it was even possible, an even bigger celebrity than Alan Shepard and Gus Grissom before him. Even to this day, the accomplishment of being the first American in orbit often overshadows the 2 suborbital flights. I think it's pretty safe to say that more people know who John Glenn is than Alan Shepard, and certainly Gus Grissom. Glenn went on to perform what was rapidly becoming the customary tour of White House visits, ticker tape parades, and various other public appearances. His spacecraft also went on tour, being displayed all around the world in what was jokingly referred to as its 4th orbit. The landing bag telemetry signal that caused so much concern was later traced back to a fault in the sensor wiring. There never was a real issue. The fault was repaired, and it was not a problem for the remainder of the program. With the main goal of Project Mercury successfully completed, it was time to look forward to more advanced flights. The scientific community had been disappointed to be denied the chance to perform more experiments with a human participant on board. The engineers wanted to correct the thruster problems that had affected both an earlier test flight and Glenn's Friendship 7, as well as attempt to be more efficient with the use of attitude control fuel and increase the time the capsule could remain in space. These tasks and more would be tackled on the next flight, Aurora 7. Thanks for listening to The Space Above Us. As always, please feel free to send any questions, comments, or other feedback to jp@thespaceabove.us, or via Twitter at the username @spaceaboveus, or via Facebook at facebook.com/thespaceaboveus. I'll see you in 2 weeks for Scott Carpenter's flight on Aurora 7. Ad Astra, catch you on the next pass.